question is designed to slowly make you see how everything fits together if you put everything together. So first of all, you're starting out with your absolute value graph. And so I'm going to draw on here my x-axis and my y-axis. And draw my standard square root graph. And besides each of these equations, I'm going to write what's happening. So the second one has a 2, horizontal or vertical. Inside the function, horizontal. Is that a stretch or a compression? That would be a compression. So that 2 inside is going to multiply your x by a half. What's new in the next one is the 1/4. So I'm not going to relabel the 2 as a horizontal compression. I'll just label the 1/4. The 1/4 here is outside, so it's going to be vertical. It will also be a compression, and you would multiply y by 1/4. In the next equation, they introduce the +3. The +3 is inside, so it's horizontal, and it will be a horizontal translation. The +3 would mean we would go 3 left or 3 right? 3 left, opposite direction. And finally, we get a +4 here. This would be a vertical translation, and you would go 4 up. So when we're asked to graph this final equation, we could graph this one, draw it, and have a new graph, then add the next thing, draw it, and have the new graph, and draw the next thing, and draw the next thing. And it would be a lot of drawing as you go along, which might make your final thing look confusing and also make it a little bit difficult to see what actually happened. What we're going to do is we're going to take this new big equation, and I'm going to underline it in green because I'm going to graph it in green, and we're going to go from left to right, starting with vertical compression and horizontal compression, followed by your horizontal translation and your vertical translation. So what we're going to do is we're going to take some points from our original graph. Obviously, the most important point from the absolute value graph is 0, 0. And I want you to pick 2 other points, one on the right of that and one on the left of that as well. And when choosing those points, I want you to think about what we're doing. So all the way through all of our translations, we're multiplying x by half, y by a quarter, moving something 3 to the left and moving something 4 up. What might be some nice points to choose? And why? There's no wrong points to choose, but what might be some nicer points to choose? Sorry? 1 and 1 is a nice point to start with, but then if I multiply it by a quarter, I'm going to get a fraction, which isn't bad, but then you're going to have to work with fractions. 4, 4, that'll be okay without fractions with both of those multiplying, and negative 4, 4 will also be good. So we take 3 points. Here's 4, 4. There's negative 4, 4. And what's different now that we have all of of these transformations, our rule of thumb is we are going to work from left to right. We are always going to have hello?
Yeah.
Our first set of arrows, we will do always our compressions, stretches, and reflections first. So in this case, going from left to right, we get a 1/4. That means we're going to multiply our y values by 1/4. And we get a 2, which means we're multiplying our x values by 1/2. And so above our first arrow, we'll do all of our stretches and compressions with reflections. And then we'll have a second arrow where we will do all of our translations. So in this case, we have a translation of 3 to the left and 4 up. So we go through our points now and say, if I need to multiply x by 1/2, well, this is going to be 0, this is going to be 2, this is going to be -2. If I need to multiply y by 1/4, this is still 1/4, this will be 1, this will be also 1, plus 1. Then we need to move 3 to the left, so this will be -3, -1, -5, and we need to move 4 up, +4, +5, +5. Label our new points on our graph. So I'm at -3, 4, -1, 5, and -5, 5. And we were able to graph this new graph by just applying the transformations that appeared in the equation, putting everything together. So whereas all of our examples up to now you could do just with one set of arrows, when you have stretches and translations, you do your stretches first, that's your first set of transformations you deal with, and then your translations afterwards. And we get our new graph. Now, I talked about going from left to right, and that order matters. Okay? So on the next page, they show what happens if you do the order in a different way. And in particular, we're always going to be going from left to right. So I want to think about this equation that they have, 3x squared minus 2. The order says you should do a vertical stretch by 3 first, and then translate it 2 down. If you did that, there's your stretch by 3. That becomes the blue graph, and then they move that blue graph down 2, and it just disappeared. But on yours it shows up, right? I don't know why it disappeared. I'm so sad. Okay? But I'll just draw it in. There it is. That would be the proper graph for that blue graph. If you did it in a different order, if you moved it down 2 first, and then did your stretch of 3, oh, that one shows up. The graph, the green final graph, can you see that it's different than the other graph? So if I wanted to graph the blue one, I would have to do it in the right order. And this one would be wrong. In fact, they show the equation of what this actually is if you did the translation of 2 down first, I'll make it bigger here so you can see it. you'd have brackets there. You know how brackets, you do what's inside the brackets first? They did the -2 first, so it needs brackets. And then they multiplied by 3. We do all of the stretches and reflections first, and translations last. We do it in 2 sections. Translations are always last. Technically, if I said graph this with brackets, I would get you to get rid of the brackets and rewrite this green one. Can you see if I distribute this, that would be 3x squared minus 6. So I would do the stretch first, and then I would make it go down 6, and sure enough, that's where the green graph actually ends up. So doing it in a different order will cause the graph to look correct or wrong. So we need to make sure that our order is in the right order.